afterwards, and ask about them as well. There's also Kobe in the meeting and Quentin, so the other guys from the research team. They can answer questions in chat or so during my little presentation. So the first thing is that, I said it's a special SIMD. People complained it's not fully specified. And I think this should be the fastest thing to discuss. In some sense, we cannot really fully specify it, right? Even the white paper alone is already something like more than 50 pages long. And of course, it's not as detailed as usual SIMDs. So I think if we take all the SIMDs together that would explain the whole protocol, then it would be something like 300 pages. And we're not really in the position to know all the details right now, right? We basically wrote the white paper and the SIMD for it. But there are many, many details which will be more clear when we start to implement. I mean, we started already, but somehow there will be many, many more things that we will clear up over time. We mostly want this SIMD out now because we don't want to just develop into the blue. We want to get kind of confirmation that we're on the right track. So, but I can tell you already, there's like 3 other SIMDs in the pipeline. 337 is already in a PR, which look at different, aspects of Alpenglow implementation, and they will make the protocol much more precise. And there's many, many more. So I expect something like 50 SIMDs for Alpenglow. It's in some sense really the biggest change of Solana ever, and it's not usually like you can describe something in 10 pages and then everything is clear. So that maybe was the main criticism, and I hope this will not be a huge problem for anybody. Let's go to the second biggest criticism. This is not surprisingly the VAT. Especially Umberto didn't like the VAT that we suggested. So let's quickly look at this. I won't spend most of the time on the last part, but let's quickly talk about this at least. So we have a few ways to do the VAT basically, and let me just list them. So one way is to have no VAT. We can just cap the maximum number of nodes. We have to cap it somewhere because otherwise the protocol just gets slower and slower, right? The more nodes we have, the slower it gets. 2000 should not be a problem. However, if we just cap the maximum number of nodes, then we somehow still have a problem, right? It's, let's say, more than 2000 nodes, more than 2000 validators want to participate, then basically you cannot accept all of them, right? So there's always some validators which want to be there, but they cannot be there because we have this cap. And then there will be this strange behavior, right? Maybe we choose the people according to the stake they have or something like that, the highest 2000 stakers. But then there will be, you try to one-up the guy which is currently at place 2000. There's always a race, or you have to randomly do it. But people will be very unhappy about this because they cannot plan ahead, right? You kind of want to know whether you're a validator or not, right? And with this solution, we probably cannot do that. So that's why we don't like this solution very much. Now you have the status quo, basically what currently happens in Solana. So you essentially have this 2 SOL that you spend on the votes every epoch, and half of that money is essentially burned, and half is redistributed. That's kind of what we have right now. And we tried to mimic this, but we didn't exactly copy it. Okay, so that was a bit of a problem. What we suggested in the SIMD was this, just 1.6 SOL per validator flat. And this with an additional cap at 2000, but we never will reach that. That's our hope at least. And this is fully burned. Now, fully burned essentially means that it lowers inflation, right? So if you burn money, that kind of counteracts against the money that we create in an epoch. And when I say, we lower inflation, that's kind of like a redistribution in its own way, right? So if you have a lot of SOL, and if you lower inflation, then it kind of, lower your inflation in some sense. And so Umberto's criticism here is quite clear. He says, but the problem is that not, there are people which maybe 20% of the capital is basically not staked, and they also get awarded for this, right? It's not just the validators, but also the other 20%. So it's not fully redistributed among the validators, but it's kind of only 80% redistributed. I mean, the reasoning for us was that's why we went for 1.6 SOL, a bit lower, so that, that it kind of balances out. But if you want to be very pure about it, maybe it's not exactly the same. I agree. And there was another suggestion by Umberto just to have 1 sol per epoch burned. Now, I would argue, apart from the top solution, which I don't like, the lower 3 are not so different. Okay, so that's my argument here. And I would just hope we can agree to go with something simple. The plan is to change this vet eventually. Maybe we'll change it even before we go live, right? Because we just want to think a little bit more about it. But just, agree on something simple. I think the simplest thing would be to just agree on the 1.6 sol for the moment and understand it's not perfect, and then kind of agree that we can do something later. We can discuss this later, but I first want to do the whole talk that we kind of have done this part, and then we can discuss. That's okay? Good. Okay, so let's go to the biggie. So this is the most contested. Somebody said we are, frighteningly naive in the forum with our reward mechanism, and it will be gamed for sure, okay? And, we should really look at that more closely. And I want to spend a little bit of time on this to try to explain again why we are the exact opposite of naive about it. But I hope you believe me after this little presentation, but we'll see. So again, just a little recap. Alpenglow has these votes, right? You send them all to all. You send your vote for each block to every other validator. And the vote could essentially be an upvote or a downvote. There's nothing else. Only those 2 votes count in the first round. You cannot do both, but you can do one of them. Now, I have a lot of text in this slide, and I apologize for that. But let's look at it. What is the reasoning behind how we do it? Okay, for the Alpenglow SIMD. So the idea is that I get a reward for my vote, no matter what I vote. I don't have to, think hard, what should I vote in this context? I look at, I'm just truthful. That's the next sentence. I look whether I got the block in time and whether it's correct. And then I vote, right? That I don't have to think, behind, what would others do? There's no wrong vote, right? I just want to be truthful. I don't want to speculate. I vote as soon as I can, essentially, as soon as I know. As soon as I have the block and the timeout has not yet fired, I vote yes. As soon as the timeout fires and I don't have the block, I vote no. Nothing more than that. And I essentially have to vote eventually, right? I want my reward for voting, so I have to vote eventually. So the work that I do is not more whether I vote now or later, right? So I can't just vote as fast as I can, essentially. It's also not much work. I just have to send little messages around. It's not that it stops me completely. So this is essentially how it works. It's very simple and very clean. This is the, this is the argument from the forum that we have a Byzantine validator, essentially, and call this guy Byzantine because he doesn't follow the protocol, but deviates from the protocol. Now, what this Byzantine validator does, for instance, is changes the code and votes skip all the time, okay? That's totally okay with us. We would still give the guy full rewards, okay, this validator. There's 2 problems with this attack in some sense. First of all, you gain absolutely nothing by doing this, right? Whether you vote truthfully or you always vote skip, you get exactly the same reward. You don't increase your reward by this behavior. And usually in game theory, Nash equilibrium would say people won't change their code if they cannot win anything from it. It also doesn't change the outcome, right? So if you vote skip, you're maybe, maybe some percent of the validators would be Byzantine, they vote skip, but it wouldn't change the outcome. So usually, and I talk about this later again, we are very worried about people who can change their behavior and then they can gain something from this, but this is totally not true here. And in addition, the action is completely visible, right? So we have the aggregates which go on chain later. We have all the votes will go on chain. So if you constantly vote skip all the time, everybody would see this, right? This is completely public. This is on chain. So it's not, even if you wanted to do this, kind of maybe this is a bit, strange to do it in this case. But okay, let's go on. Now, what would Tower BFT do here? Okay. That's kind of the suggested solution. Some people say, why don't you do it like Tower BFT? Okay, let's look at it quickly. So in Tower BFT, you essentially can vote wrongly, okay? So if you don't vote on the current branch of the fork, then you are locked out, and that would be a wrong vote. Then you don't get, you don't get the money for that. You get less rewards. So you don't really want that, okay? So what happens is that you wait with your vote, and you first check what others vote, right? This is a very logical way to do things, I would say, right? Like if I don't want to vote on, don't want to be on the wrong side of the vote, then I, wait and see what others do. Now, because of this, the whole system got slow, right? People wait more and more to see more votes of the others. Nobody wants to vote, essentially. So then we had to introduce something to mitigate this problem, right? And this is the timely vote credits. Now, with the timely vote credits, again, you are somewhat incentivized to vote early because then you get higher rewards. Note, however, that you don't have to put your vote in the first possible slot, because maybe for some people who are very far away from the center of action, this would not even be possible. So they gave them a little bit of slack. They had 2 slots that they can do that, just to make sure that the people, let's say the person from Australia, also has time to always get the highest rewards, because he has 2 slots to get the vote in. Now, if you have 2 slots to get the vote in, the person in Amsterdam, which is maybe very close to the center of action, actually has a lot of time again to see all the votes first before voting, right? So you see this game of strategy, even so Tower BFT tries to solve it with this timely vote credits, it does not really even solve it, okay? So it's actually still possible to strategize, which is a big difference from the left-hand side, where you cannot strategize. You cannot, being truthful is the best you can do. And that's a big difference. And there's a meme for this, really. I mean, there's an exact meme for the problem we have here. So in Alpenglow, that's the top one. Maybe you know the meme. You just vote truthfully as soon as possible. There's nothing to gamble here. That's the best course of action. You make most rewards that way. And, in the tower solution, you first speculate with the vote, then you delay, then the system gets slow, then you have timely vote credits, then some validators maybe still don't get the full rewards, and others can game again. It's a huge mess, okay? And so we in the research team, at least, we think the top solution is much, much better. It's cleaner, and there's no possibility to game it. But, okay, so for the sake of, burying the hatchet, okay, let me still propose a solution for always vote skip, okay? If you think this is a big problem, let's propose a solution here, okay? So the idea is you punish the validators that send too many skips, right? By, for instance, reducing their rewards, right? This is sort of what was suggested in the forum. That, that sounds very reasonable. So let's try to do that. Let's make it a bit more concrete, right? Because if you don't make it concrete, then it's difficult to argue about. But here's my concrete proposal for this. So what we can do is, since we have all the votes, whether skip or notarize on chain, in the aggregates, we just punish the validators that send twice as many skips as, let's say, the median validator. Okay? So I hope this sounds good to you. Would that work? Somebody has, I see thumbs up, so people like this. So maybe you think this is a good idea, but turns out it's not a good idea, okay? Very surprisingly, okay? So let's see why. Okay, so this is the concrete plan that we just proposed. We twice as many skips as the median validator, we're going to punish you, okay? So this has severe side effects, actually. It's a very bad solution. So you could have some sort of radical slot stretchers. We have them already today to some degree, but let's say in the future, we design a system for the future. We have a slot stretcher which tries to reach only the 60% stakes that we have in Europe, okay? Why do they do that? Because, slot stretching gives you maybe more MEV, and it's actually enough to get the 60% in stake in Europe twice. So you stretch the slot so that for the guys in Europe, okay, think of the leader also being in Europe for a moment. For the guys in Europe, they still see your block before the timeout. Everybody who's further away from you will not see the block before they have a timeout. So they would vote skip, if they vote naively. They always send skip the others. So now you have exactly the problem, right? So the median guy is a European guy. He always sends yes, right? And all the others always send skip. So we have, of course, more than twice as many skips from the guys outside of Europe than from the guys in Europe. So what happens next, right, is then you, of course, say, well, should I have an operator in Australia or, even, let's say, slightly outside, even in New York, right? So in that sense, you will, of course, move your stake to Europe, right? And then you have centralization. So you see, I got lots of thumbs up before. I looked at my screen very carefully. By just saying this, and now we can see it doesn't work, okay? And this is essentially where we're coming from. We looked at so many of these things, and the system we have actually works, and all the other things we looked at don't work. So I know that there are some hands up, but let me finish, okay, and then we can discuss. So of course you can try to make it a little bit better, maybe you don't go for the median because of the 60% problem. You say you don't want more skips than, let's say, those which send actually already a lot of skips. But, believe me, this is not, this is still difficult, okay? It's difficult to argue here. And weirdly enough, whatever you believe is the common sense here, and whatever you believe was a good solution so far is actually not a good solution, okay? So that's the honest truth. So let me have one more slide just to finish up. So what we absolutely don't want is we don't want validators who deviate for profit, okay? So if you have a possibility to kind of change the Alpenglow protocol a little bit and make more profit, that's absolutely catastrophic. So we all agree on this, okay? That's, if you have this, then of course people will do this, right? We are not naive, okay? This is exactly, we believe that very much, okay? I would do it, okay? Everybody would do it. So, but Alpenglow does not have this problem, okay? We can prove that you cannot deviate for profit, okay? So it's the best course of action to just stick with the protocol, and then you don't make more profit. Okay, deviate for X, I just see Santetsu here. Deviate for reduced cost. Okay, so that's the alternative, of course. That's not great at all, okay? So of course we don't want to deviate, let's say, to reduce cost. But it's super difficult to solve this, okay? So we tried, of course, we looked at this for weeks and weeks, okay? And we don't know how to do this, okay? Nobody knows how to do this, actually. So in Alpenglow, we cannot deviate for profit, so I can guarantee that. In the other case, you have to put a lot of crypto in place, okay? So Alpenglow is a protocol where you basically talk directly between validators, right? And so to make sure that you always do all of your jobs right, you send around the shreds as relays in rotor or turbine now, and you vote correctly. You send all the, you send all your votes timely, not just the ones which matter most, and so on and so on. So we don't know how to do that. We try to do that, initially, of course. I, for instance, was very much on the right-hand side, right? I felt we need a protocol which can solve all of this, okay? Where you cannot deviate at all for no reason. And it was really, what is called here, what Kobe called the crypto delirium. The crypto became so big, right? So the overhead to just check everything is like, 100 times bigger than the actual protocol. So your throughput goes down 100x, okay? Just to make sure that you can check all those cases, and still we couldn't do it, okay? We only could check very little things with it, 100x more, bandwidth use, which is a real problem. And it's not just us, okay? And let me give you an authoritarian argument as well. So Max Resnick at some point jumped in at Anza, the kind of economist, okay, who looks into these things, okay? And he also tried to do this, only for votes. He tried to find a protocol where you can make sure that you cannot deviate at all, okay? And he started to write a paper, how to do that, and there are a lot of holes in that paper. Then he started to talk to A16Z. So there's Pranav Garamidi here on the screen. He's like, the whiz kid at A16Z Crypto. And, he tried to help him. Then they went for Wamsi, which is, one of the smartest guys I ever met, who tried to help. Then there's Georg Fuchsbauer, he's a crypto prof, tried to help. Nusret tried to help. And in the end, we talked to them throughout the whole process because we were also very interested to have this. And in the end, everybody basically agreed that we cannot have this, okay? There's no protocol. It's an unsolved scientific problem. I would even bet that it's not solvable. We probably can find a lower bound, that the amount of overhead you have, if you really want to prevent deviation at all, would be huge. And we have this issue in all the protocols. Alpenglow will have it to some extent. The current Solana protocol has it, totally has it, okay? So you can find tons and tons of places where you can deviate to, let's say, save work or something like this. Actually, in Tower, you can even deviate, as I said before, to make more profit. But deviate to get less work, this is also possible. Good. So that's, that's in some sense the summary. Since the question is what should we target, we should target we absolutely want the protocol where you cannot deviate for profit, and we have it with Alpenglow. We have it exactly with the reward system that we proposed. You cannot find a way to make more profit with that reward system. And it sounds very naive, and I understand that. I also felt it was very naive first, but that's the best we could come up with. If somebody can come up with something better, great, but I really doubt it, because really some of the smartest people in crypto science, so to speak, thought about it, and nobody can solve it so far. Maybe in the future we can solve it, we can improve it then, but right now we just don't know. But we can solve the deviate for profit problem, which is the much bigger problem. Good. So with that, I want to open for discussion.
Dan, if you want to go ahead. I don't know if you're just asking in chat or Zentetsu, go ahead.
I'm sorry, I didn't hear what you said. First of all, I want to say Alpenglow is awesome. I'm not here to criticize it overtly, but there is that one piece that we're talking about right now that I think deserves extra consideration. You've done a very good job presenting a lot of points for why this extra consideration is not needed. But I would like to point out that some historical evidence shows that as much as we'd like to believe that validators are kind of always going to do their best work, they don't always do that. And having the protocol provide incentives for validators to perform better can have an effect on the overall performance of the blockchain. I can share, if you want, a couple web pages that I put together to sort of demonstrate what I'm talking about, if you're willing to let me share. And I hope that it shows that it's at least worth considering this topic. And I also want to point out that, as I said in a forum post, I think there's a difference between honesty and hardworking. And I think that Alpenglow does a perfect job of incentivizing honesty. And, but I'm not sure that it does the best job of incentivizing validators being hardworking. You can be an honest validator that's just basically phoning it in. You're running the standard code, you're running on a machine that you think is capable enough. And, as long as nothing in your reward scheme shows you that you're deviating from what you should be doing, then you're fine. And what we end up with is a large body of validators that kind of aren't running on the most optimized systems, and they're still getting maximum rewards, so they have no incentive to change. And that's what
I don't disagree with you. I fully agree with you, okay? That there's absolutely the possibility to phone it in. This is also true right now, right? You don't have to send any shreds forward in Turbine. No, there's no punishment for that. You don't have to. You can even send the shreds to somebody you like and not the other guys. You can, not do the gossip. You can,
if we could incentivize all those things, wouldn't you want to? If we could somehow come up with a mechanism for doing it, wouldn't you want to incentivize those things just for an extra layer of sort of like incentives to keep the blockchain running smoothly? You would want to if you could. And TV showed that we can't incentivize that. Sorry,
exactly want that. We don't know how to do that.
No, I understand, but TVC showed that we do know how to incentivize fast voting, at least. That's what it does. And I'm just saying that in Alpenglow, we're kind of taking a step back from that perspective. We're basically saying there's an eight slot window that you get to get your votes in for any votes on slots in that window, and as long as you're anywhere up to the 7th slot, you're going to get full credit. And honest validators, which are definitely the majority, are not going to deviate from that. They're going to vote within that range. But are they going to vote as fast as they can within that range? Do they have incentive to have the best performance they can? No. And from the majority of the stake, that's not going to matter, because many of us try hard to do our best, and we actually do care about these issues. But there's a large amount of stake that won't do that, and they will never know. And not only that, since there's no way to measure, how anyone is performing with respect to votes, because all you get is a summary after 8 slots of like all the votes whenever they happen to happen. There's no way for stake pools that right now are kind of an influencing factor in driving, you know, validator performance to even have a metric that they can use to rank validators on. This could be for better or for worse. And I'm not saying that Alpenglow is going to fail because of this. I'm just saying we're going to miss out potentially on some benefit.
So there's no measuring on chain. This is true because we don't want to use the chain for everything. You know, we don't want to have the overhead on chain essentially. But we do have metrics, okay? So what we will do, is that all the validators basically report about the other validators. So essentially, after the end of the epoch, you would tell about all other validators how you think, well, how good the job they did. And, you know, this is not on chain, okay? Not at all, because we don't want to make this public. But we do have it, okay? So if we see something, we can actually think about things that, you know, how to punish these guys eventually. I don't mind doing that, actually. But it's a very double-edged sword, right? Because you know, sending in your vote late could mean that you actually send in your vote late. I mean, you have no reason to do that, but let's say you still do it for some, you know, because you're a Byzantine, essentially, right? Or it could mean that you're just, you know, geographically a bit in a bad location, right? And we don't want to punish those guys. So we have to be careful about this balance there.
Yeah, I agree, and that balance is difficult. I think the geographic thing is a little bit overblown. If you look at the actual credits achieved, it's like within a fraction of a % difference it makes to be in different parts of the world. The reason that we have a problem now is because a lot of larger stakers, such as stake pools, have historically considered to the nth decimal place as a ranking criteria, and that just means that immaterial, you know, differences can make big differences in how a validator gets staked. I think there's a good solution to just not go beyond, say, 1 or 2 decimal places in terms of like performance, and after that, say it's all equal and stake based upon, you know, not such very precise criteria. But your points they're valid. They're not invalid. I'm just going to say that, you know, to me it's a little bit unfortunate that we went through this process once already of seeing the validator set become complacent, seeing Solana not achieve the block times it could, and then putting in place a method which arguably has some issues around, you know, geographic location that we just discussed, but did have an impact. And I can share my screen and show, you know, show like what that was. So are you seeing the block time chart right now?
You see your screen, yeah.
The whole screen? So you see this block time chart?
I see good performers list, that's all.
Oh, I'm sorry. I'm sorry. Share this tab instead. Okay, how's that?
Yeah.
Okay, so I don't know if you've looked at this. I'm sorry I was late to the meeting. I had something I had to deal with. But you know, we can see that this red area is essentially what happened after the introduction of TVC. And we can see that before that, there was a trend upwards, maybe a general trend upwards. You know, new software releases happen as this corresponds with V2.0. So, you know, there obviously were changes that happened just as a matter of improved software. So some amount of improved performance could have come from that. But I think the fact that it's a gradual decline from, you know, a starting point that's relatively close to what was happening in 118 down to a minimal point, which is where we are now, where block times are under 400 milliseconds. To me, that's very clear evidence that what happened was suddenly there was incentive for validators to improve, and over time, the entire set slowly improved. Validators got faster, they put in better performing hardware. This trend did not occur previous to this at any time. Like this is, okay. You know, if the software itself was only the reason, it would have immediately dropped down. Sorry,
I completely disagree with you, okay? But I'll let Kobe make the argument, okay? Because he made it in the forum today, and I think it was a good argument. Maybe Kobe raised his hand, maybe he can say it.
Okay, well, I don't know how you see this otherwise, because I would think a new software version would immediately drop down to a lower, or very quickly drop down to a lowest point.
Let Kobe explain, and we go from there, okay?
Sorry, go ahead.
Sorry.
If someone else wants to explain that.
Sorry, I just wanted to ask, this is mean block time, right? So, right?
Right.
If you can make the connection
right.
between mean block time and timely vote credits.
Right, because validators are voting more quickly, so blocks are being confirmed more quickly. I don't know, that's an interesting point. I mean, this is block time, not time to confirmation. I guess I thought this was more like, is this like a confirmed block time? How long it takes to confirm a block? I thought that's what it was, not how long like someone measured shreds to be completely received for a block somewhere. I thought this was confirmation time.
Yeah, I'd be curious of the source as well, because we don't have a great block time.
I mean, I
think the source is my Twitter. This is comparing This is the comparing the timestamps for like epochs and dividing by the number of slots. So it's block production, not block confirmation.
Oh, okay. Well then.
Oh, so
All
you're
right.
basically just measuring epoch times with this.
Yeah, epoch. Yeah, exactly.
Got it.
But validate, I don't know. Maybe it's. I mean, this is knock-on effect. Validators improve their performance in order to get better vote times, and as a result of having better performing validators, they emitted blocks. Their block times went down also. So yeah, I mean, the difference here is roughly 10%, from like 450 to just under 400, maybe a little bit more than 10%.
No,
So if we could say that 10% of the cluster got significantly faster, that that their block times went down, or maybe 20%. Okay,
No,
so
but-
maybe this is not demonstrating it as clearly as what I thought it was. But I think there's some.
No, Kobe, can you make your argument, please, or I make it? It's also fine, but please.
I have many arguments, but I wanted to see. Also wanted to listen to all of the arguments that Tetsu wants to make.
Okay, so putting this aside, this may or may not demonstrate that TVC was effective. I could still argue that I think it was, because I think that the decline would show that, but that's very arguable. I'd like to go over and show this. This was, I had for a long time been publishing this webpage to kind of keep track of like who the worst performers were, because this was a real issue, a year and a half ago. And this is a snapshot of what things look like right before TVC came along. The average vote latency was 2.06. And in fact, the deviation was so high that I considered, my algorithm considered poor to be over 10 vote latency, which is ridiculous. I mean, it should have been much lower than that, but that's just the way the algorithm worked out in this particular epoch. But as we go down, we can see that, vote latencies of 2, 3, 4, and these are sort of by stake amount, by the way. This is over 3.6 million stake. They were not uncommon. They were very common. 5, 3, 2, very common. Now, if we go to now, it's 1. In fact, this is the poor list. So the number of poor validators is so vanishingly small right now that I can only even look at these tiny little validators that have 1.3 or 1.1, and they're considered the worst performers, 1.9. So for whatever, I just feel like this demonstrates that like rewarding vote performance does cause faster voting. Is that important in Alpenglow? I guess we'll find out. But
So
missing out on that, I think, is a step backwards.
So let me quickly just say, I fully believe that TVC was super important, okay? I completely agree with you there, okay? I understand that before TVC, you had a real profit if you just waited for others to vote, and then you voted basically what the majority votes, okay? That's very clear, and TVC was in some sense helping that. However, and now I'm going to make the argument Kobe made, but let me just say it myself. One part of the argument for TVC back then was something else. It was about potato hardware, okay? It was about people who are basically not be able to keep up. But if you really are not being able to keep up, then basically you would fall behind more and more and more, right? If you
but then a skip happens and you catch up again. That's what the pattern was. A skip happens and then you have a full, maybe a skip of 4 slots happens. You have a whole like 2 seconds to essentially catch up. And that's the pattern that those potatoes were in. Falling behind, then catching up, and falling behind, then catching up.
All the I have seen these statistics as well before, right? And I fully agree that the times went down to basically most of the things, more than 90% of things are basically in the next slot, right? More than 90% of the votes right now.
Right.
And I fully believe this is, not because of potato hardware so much, but I fully believe this is because of timely vote credits, because people don't stretch their voting anymore because they don't.
That was a very small fraction of stake ever did mod games where they tried to deliberately delay. It was a very small. The potato, I think, was a much bigger factor involved. And what's going to happen is Alpenglow is you're no longer going to have that pressure, so that you're not going to have validators. Well, over time, at the beginning you will, because we already get super optimized on our hardware. But over time, the validator set will age, and we have no incentive. Like I have no incentive to improve my hardware. If it doesn't matter if I vote after 1 slot, 2 slots, or 3 slots, I get the same credits. Except that, like you say, if you're continually slow, then with a low skip rate, you're eventually going to fall way far behind. Mm-hmm. We used to have like a double, like the slow voting happened, and we had like fairly high skip rate of like 5-6%, which was enough to create this equilibrium where validators kind of went behind and came back. So maybe we'll all like not be able to become potatoes just because the skip rate's low enough now that we can't.
We can easily fix this by just putting the first thing into S+1 instead of S+8, right? If you think that helps, I don't think it's a problem. But if you think that helps, we can do that, right? It's a bit a problem for those which have validators far away. But if
S+1 or S+2, to give a little bit of grace. Why not consider it is all I'm saying.
No, why S+2? Why not S+1?
Because this is for the same reason we went through all these arguments, and I'm sorry, Kobe, we'll get to you in a second. For the same reason we went to all these arguments, you know, back when TBC was proposed about whether or not we should have a grace period to allow more distant validators to have a chance to not be right on the edge of performing poorly because of that. So that's the only reason I have S+2 is because it historically matches what we've done and decided previously. But it could be S+1 if you want to be even more tight in the criteria. I'm sorry, go ahead, Kobe.
I have quite a few. I mean, I have many directions at which I want to disagree. I don't know which one to pick, but one is you mentioned 5% skip rate would be. I mean, this would have to be the margin by which potato is underperforming to keep up, which would be a very finely tuned potato, right? Which you have to.
Yeah, and they were. I mean, you could look and see that they were like that. I don't know. There's no way to. I mean, that's probably why that was a small.
I mean, there's a few more things that I think a few more things about which it's easy to make a confusion. I think so. One question is, would there be vote delaying in Tower BFT? Yeah, there would be. There's reason to delay your votes, right? And this we can all agree. Yeah, and then introducing timely vote credits, it would reduce it. We can agree about that. This is all true.
Right. Yeah.
Yeah. This is a problem of Tower BFT. This is
and potatoes.
Very bad thing where not necessarily a potato. If I have a very good hardware, okay, I still want to delay my vote because then I can see I don't vote wrongly somehow, right? Then I can pick the
don't equivocate the two. There's voting slow for the specific design purpose to increase credits, and there's voting slow just because you're running stock hardware or you're running stock software, but you just happen to have a potato. Those are two separate things.
Yeah.
So I agree with you. The assessment of Tower BFT enabled the first. Alpenglow and Tower BFT enabled the second, which is potatoes.
Yeah. So the latter seems unlikely to me, this 5% skip rate and you being exactly 2% below the performance you would have to keep up. I mean, okay. And then you would also lose a ton of money when you're a leader, if you are underperforming, right? So it all seems very, how to put it?
No, it's true, but it's a very strange stochastic system. Like we get into these, I think, maybe I'm wrong, but we get into these like equilibriums that you think, how do you get there? It's because just enough validators were slow enough, that just enough validators could be slow enough, that just enough skips happened, that just enough, like, that's my belief, is that we end up in these equilibriums, and that, you know, changes in incentives and then challenges in validator performance take us out of those to different equilibriums. But, okay, you know, it would take a lot of data analysis to really prove that.
Another question for me, from me. So would it improve your vote latency if you moved from Sydney to Amsterdam?
Yes.
Yeah, I mean immensely, right?
Yes.
You can't have
not immensely. If you give a grace, if the grace is sufficient, which I think it is, the difference is in actuality are small fractions of a percent. Unfortunately, we have, you know, those become important when they're featured in leaderboards. This is a fortunate problem we have right now. But
yes, one more question. Can I make a mod that would let me like skip all of the execution? I don't even execute. I just look at some votes in gossip and I vote like them.
It's easier to just parrot someone else. Just wait one slot, see what my favorite validator voted, and I just copy their vote.
Exactly. There's also votes
degenerate. I just look like a regular dude who's not really validating. You know, looks like a validating, but I'm not really validating. I'm just parroting someone else.
All right. So is it then? Do we agree that despite timely vote credits, it is possible to not even execute at all, but vote like the majority and timely?
Except that you'll lose credits because you'll be, if you wait one slot.
No.
First of all, no.
So I'm in Amsterdam. I look at gossip. There's also votes in gossip in Tower. And I can look at some votes that vote for some block. I mean, likelihood is.
Tower, if you don't vote with the supermajority, you don't get credit. So you can't just vote one way forever or something. So you have to kind of at least vote. At least the best you can do is parrot someone else, and if they're accurate, then you're accurate. Although slow.
I understand. If you're in Amsterdam, I'm saying you can parrot someone else with the latency of say 50 milliseconds. That's what I'm saying. Which
potentially.
Is Amsterdam block.
Potentially, yeah.
So, okay, the guy in Amsterdam, he can still not execute, and he can still wait a little bit to see the majority voting something. He can still deviate from the protocol, and he can still have very poor performance, and he's still better off than the guy in Sydney, right?
I don't know. You're getting into fine. I mean, generally, your point is sound. Like this kind of parroting is still possible in TVC, and it's likely that it wouldn't result in so much latency that it would significantly impact your credit's performance. And in fact, it's only because 1 credit difference or 5 credit difference out of like 5 million makes a difference in leaderboards that I could say that actually it would make a difference. But that's only because we are cutting these things so stupidly finely right now, and we don't want to do that. So in the case where we really only go down to 1/10%, then absolutely, I think your point is sound.
I want to make sure, just to jump in real quick, we have time for other questions or comments.
I think I've said everything I wanted to say about this. I will still support Alpenglow. I just wanted this issue to be fully addressed, or at least considered. And I believe we have, at least I feel satisfied with what I've heard. So thank you.
A couple of things I want to add for context. So over the past couple of years, there's quite a lot of confounders that I just want everyone to kind of keep in mind, keep context, right? The Agave software performance, I think everyone can agree, has improved immensely over that time period. So that's one confounder where block times would definitely increase. There'd be a lot of improvements that we are seeing that aren't directly related to TVC, but also related. Another big thing is that the on-chain economy has changed dramatically over the last couple of years, right? A couple of years ago, the majority of the profit for validators was from inflation, and now it's not. And the majority of validators also take 0% commission, where that was not the case before. So I think that's also worth keeping in mind, that there's a lot more incentive to produce good blocks than there was back when potatoes were really common, because people didn't really care about block rewards nearly as much as they do now. The last thing I want to point out is that, what was my last point there? Oh, yeah, that a lot of the problems were also the foundation's fault, right? I mean, a lot of those potatoes were in SFDP, and they were artificially kind of being propped up. There was also problems with, highly staked nodes that were potatoes that didn't really seem to care about their performance. But I would say kind of the long tail there was definitely SFDP in some cases. So I think there was a whole constellation of things that led to performance improvements of the cluster. Just want to make sure that we don't assign it just to one change, which I think TVC was really important and really beneficial, and also a monumental effort. But there are a lot of other factors that led to changes, and I don't think the same outcome is as likely today as it was 2 years ago. Anyway, that's all my 2 cents. Is there anything else anyone else wants to raise or ask? Yeah, Chris, go ahead.
Hi, everyone. Could we shift the conversation for a couple minutes and talk about the scope of this SIMD? I mean, we've gone back and forth in the forum, but I wanted to be very clear on what the scope of this SIMD is. And then I'd also be curious to, I guess what I'm really trying to figure out is, what are we voting on here? We're voting on a signaling proposal. So yeah, I mean, I just really would like to understand what the scope of the SIMD is. And then I'd also like to understand the implications of, for example, voting yes on this SIMD. And then when other SIMDs come down the pipe, are we committed to having already voted yes on those, or will there be opportunities to pivot and continue the conversation? Because I guess one of the things that I'm concerned about is that we vote yes here, and that just opens the door to yes kind of all the way through into whatever the implementation looks like. So I'm wondering where the checkpoints will be along the way to make sure that the deployment here is on track. And then I guess in conjunction with that, I'd also be curious to understand what type of testing has gone on in the background, and then what the general deployment and rollout plan would be looking like in the team's eyes here. Just to really understand, if we're voting yes on this, what are we voting yes on? What does that commit us to or doesn't commit us to in the future? And then what type of testing has been going on? I imagine this has been tested in some private cluster somewhere, and then it will be rolled out to testnet and rolled out to mainnet. But I guess for me to get more comfortable, I'd really be appreciative to understand what the scope of the SIMD is and what the implications are for future SIMDs, and then just understanding what type of testing has been happening and what type of testing and rollout plan is contemplated as we move forward here.
Okay, I mean,
as far as the scope, oh, sorry, go ahead.
I mean, the scope of the SIMD I can answer more easily, right? So it's in some sense to give us a green light to develop Alpenglow, right? Because we don't want to put, years of work in it, and in the end it says nobody's interested in this or something. So we want to get that. In particular, I would say it's for the voter part, because we keep turbine initially, as the SIMD says as well. So it's only for the voter part initially, because those two are compatible. And then we also want to have, to have your okay for the initial VAT and the initial reward scheme, as basically discussed today again. I think these would be the main things about the SIMD. And then, the other SIMDs, apart from maybe Rotor, which will also be a bigger one, but many other ones are more technical in nature, right? It's not such a philosophical SIMD of a big change. We just look for the best solutions everywhere, right? And if you can argue at some point that this is not the best solution, or somebody says, that then of course we can vote SIMDs down, or go back to the drawing board if something comes up. So that's all open. But for me, it would be important to have sort of a green light, so that we don't, develop into the nirvana, which is never used. And then for testing, maybe there are better people in the room to talk about this, but the implementations are ongoing. I can say as much as I know at both Anza and FireDancer. We talk with each other to try to, iron out all the things where the white paper or the SIMD was not accurate enough. And so we still have a few open problems which we haven't quite solved, right? So for instance, the migration from Tower to Alpenglow is something we still discuss. We believe we have a nice draft already, and we'll release that at some point, but that will be its own SIMD, but it's more technical nature, right? It's kind of like, it will be the best path for us for the migration, but maybe somebody else would say, that there's this or that problem, and of course we listen to that, right? Yeah, so that's roughly what I
I
would
don't know if Ashwin or Wen want to add anything to status on Alpenglow, or whoever else on the call from Anza.
Can you hear me?
Yeah, go for it.
Yeah, we've been developing Alpenglow in a private repository basically since February. We've been running successful private clusters. There's still a bunch of features and also rewards that we have to implement. The past couple of months, we've been upstreaming some of these changes to Agave, and we also plan to test on larger private clusters. We have the Validator team helping us with crafting like malicious attacks, and we definitely want to test on that in the next coming months as well. And then once the full upstreaming to Agave is complete and we feel pretty confident about the changes, then we can begin testing on testnet. As Roger pointed out, the migration still needs to be figured out, and that will be something that we want to test a lot. So probably doing a lot of upgrade, downgrade scenarios on testnet until we feel that we are pretty solid in that area before moving to devnet and finally mainnet.
Cool. Thanks, Ashwin. Matthias, if you want to go.
Yes, thank you. But I guess Ashwin partially already answered it a little bit. I just wanted to ask, because I didn't understood it 100%, that when Roger, you in the beginning, you mentioned that the criticism number one was that like not all the details were known. And then you said like you don't want to develop into the blue. So I got it like, so let's ship it. So we have some live data, we have some metrics, and then you can improve stuff or something like this. I just didn't got exactly what you meant with like what is not known yet and what do you want to find out while we run this.
Yeah, I mean, when you write the white paper, right, it's like a piece of law, right? And then once you run the law, you would see there are some things maybe unexpected, right? And I think this is something we take very seriously, right? When we wrote the white paper initially, Quentin essentially developed also a client, and he built the software. And when you build software, you have to understand all the details much better than just writing on a paper, right? On a paper, you can write all sorts of things, but when you actually build the software and you say, oh, how was this actually meant? How can we do that? And I think we will see some of these things while we are developing, right? That we maybe are not always 100% sure, whether everything will iron out nicely. So that's why, I mean, the white paper or also the SIMD or whatever we have so far, we believe is the best we can do, but just while developing, we will see other, things that might happen. Somebody's talking at the same time. Yeah.
All right. Thank you. That answers it. Thank you.
Any other questions people want to ask? Zan, go ahead. There's no one else.
So I am just curious if you have any assessment about, should we go back into sort of potato territory where, say, 15% of the cluster now votes kind of slowly? How does that impact, the numbers that you believe would be achieved in terms of, time to finality? Is that generally just increase it by some number of slots? Would it go from an expected 1 slot to 2 slots or something like that? Or do you have any insight into, is this issue even important? Like, is your system already so much faster that it won't matter that much if people are voting, 50% of the cluster is voting 2 or 3 slots behind?
I mean, we usually don't compute in slots at all, right? For us, it's really milliseconds because we really want to be finished within, less than a slot, right? Like we want to do it 150 milliseconds, which is 3 times less than a slot. And we can deal with nodes going behind, right? So that's sort of the whole proof, right? We can deal with 20% Byzantine nodes, which not only do nothing, but actually actively try to, jeopardize what we try to achieve. And we can also deal with 20% nodes which don't work, right? Which kind of are completely silent. So this is all proved in some sense, at least in theory, right? On paper again, that this works. In the testing, of course, we will test exactly that, right? We will test these sort of, having that many nodes who do this kind of attack and that many nodes who do that kind of attack. That's of course on our menu to do that. Kobe, yeah.
Well, I guess what I'm saying is that you propose that Alpenglow will produce much faster time to finality. I believe I'm sorry to not remember, but I believe you're reducing the slot times. Is that right? They're reduced from 400 to something smaller? No, it's still 400.
No, at the beginning we will have 400.
Okay.
I mean, we could probably do that.
Okay.
But it's a question whether we want to do it. But at the beginning we'll stay with some things we want to keep just to have continuity and not change everything at the same time.
And there is a knob that can be tuned, like you said, the S+ knob. So instead of S+8, you move it down to S+2, and we say, okay, now we're pretty much the same as what TVC was. You better vote within 2 slots. And the only difference being that since there's no way to measure slot by slot when votes were cast, everyone kind of gets two. You can't tell the difference between someone voting in an average 1.05 and 1.75, or you won't really know the difference. But in the end, it may not matter. Maybe this will be so much better and faster that these minor differences at the boundaries won't make a difference. I hope that ends up being true.
Yeah,
that's all I had to say.
I just want to say that performance, right, and incentivizing performance, everyone agrees is beautiful, very good, important, and we should have it. It's just that and timely vote credits, okay, as long as the deadline for the timely part is reasonable enough such that centralization does not give you advantage, this is also good. And we have right now this S+8, right, which is just being a bit careful, but anything that's reasonable, yeah, we agree with this. It's just that pushing this timely part too much, we disagree that this is a good proxy for performance. And then, yeah, it would be a huge problem, right? If 15% is too slow, and then really they can have bad hardware, but they don't care, that would be a big problem, and we all care about that. But again, I think today the reason why they don't is the being leader part, and in Alpenglow that would be the same.
Chris, go ahead.
Last question. In terms of deployment, would voter be pushed to mainnet before rotor, or would voter and rotor be tested on testnet together and then pushed together? I'm trying to get a feel for the sequence of steps.
As it stands now, voter will be pushed before rotor. So we first do turbine together with voter, and then later have another SIMD and then push rotor. We could have done it the other way around. I mean, you're not wrong about that. The other way around could also have made sense. But this was at some point decided that we first push voter. And I would say the reason for it is that voter sort of replaces the worst piece of the software, whereas rotor replaces something which is already good.
Okay, thanks.
We're at time. Any last second thoughts or questions? No. All right. Well, thanks, Roger, Kobe, Quentin. I'm sure is hanging in here too, and Anza people for being here and answering questions. Voting starts, and well, actually, we're taking a snapshot of stake in epoch 839, and then voting will begin in epoch 840. The forum is the place to make your sort of stance or opinions known, and of course, there's a conversation in MB planning as well. Yeah, I guess I'll see you all in the forums.
Yeah,
thanks, everybody.
Please ask more questions in the forums or so. I think we're happy about that. Yeah. Thanks, everybody.